Welcome intellectuals. So we are going to do tutorial sheet 1, physics 101. The topic is measurement and units. This is the tutorial sheet for this academic year 2025. Okay, so the way this tutorial sheet is prepared, it has questions learning from simple questions up to questions which seems to be a little bit complicated. So as long as you are preparing for test 1 and exams, you need to be able to solve all questions from this tutorial sheet. And this is what I'm going to be doing. I'll be fast on parts which are very simple for you to understand, and those that needs me to explain, I'll be explaining. Okay, all I want is to finish this tutorial video on time so that we don't take much of your time on just one video. The full tutorial has got how many questions? I'm sure it has 24 questions. Okay, so the first question is on standards of length, mass, and time. And you can even tell to say they have told you to say that the questions are what are easy there. Okay, that's how the instruction is. Okay, so now the question leads, what is the standard unit for length? Okay, and how is it defined in modern terms? Okay, the first thing you need to know is that the standard unit for length is actually meters. Okay, it is meters. Now, how does meter is defined in modern terms? So you need to know that meters, it is just a distance light travels in a vacuum. Okay, in one pair, I'm going to give you this number. Okay, it is a distance, say a distance light travels in vacuum. Okay, that is W. Light travels in vacuum in one pair 299 million, then 792,000, then 458. Okay, 458 of a second. So this is how we define what? This is how we define meters in modern what? In modern terms. Okay, what about question? Let me check if I still have another question following, or I should just use this same board. Okay, so question 2, I should answer it from here. Name the SI unit of mass, okay, and time, and briefly describe their current definition. All right, so the SI units for mass, the SI unit is kilogram, denoted as kg. Okay, now how do we define this? Okay, this is a SI unit of mass, guys. Okay, it is a SI unit of mass defined by fixing Planck's constant there. By fixing Planck's constants. Okay, you can even include Planck's constant to be our h to be, let me write it here. Planck's constant is denoted by h, small letter h, to be 6.6260 60715 times 10 to the power negative 34 joule per second. This is going to make sense in the upcoming topics. In chemistry, we will talk about Planck's constant. Okay, so what else do you need to know now? We are also being asked about the SI units of time. Now the SI unit of time is actually seconds, denoted by a small letter s there. Okay, now a second is defined as the duration. Okay, this guy is there. You can't even be asked this, but you need to know, since it is included in your in your tutorial sheet, it means it is important. Because how I know that some questions sometimes in the tutorial sheet, not all are important for exams, but for revision sake. As you can see, this are all coming from your notes. Okay, this is a duration of 9,192,631,000 then 770 periods. Okay, say periods over periods of the radiation of cesium 133 atom. Radiation of cesium of 133 atom there. Okay, so like on definitions, guys, I'm not going to waste much of my time because there are a number of questions here which we need to answer, which are very, very important to your exams. So starting on question 3, at least things have started changing because though it is very simple, it is one of the important parts of this draw sheet. Okay, to convert 5 kilometer to meters, we are going to say 5 kilometer. Okay, to cancel kilometers, guys, we must have kilometer down there, and 1 kilometer is made of 1000 meters. This is what I was showing you since we started dimension analysis, so that kilometer and kilometer will cancel, and 5 times this, we're going to have 5000 there, 5000 meters. Okay, this can also be written as 5 times 10 to the power 3 in scientific notation, but leaving the answer as this, there is no problem. Okay, question 4. How many significant figures are in the number? 0.00560. Let me check if there is no space, so meaning I should just answer from here. Okay, how many significant figures do we have? Okay, let me just tell you about tools which are going to help you answer this kind of a question. Number 1, all non-zeros are significant. All non-zeros are significant. This is what you need to know first. So that means 5 and 6 are significant. So we have 2 significant figures. Okay, what is the other thing we need to know? The leading zero. Okay, the leading zeros are not significant. Okay, leading zeros are not significant. You need to know these laws are not significant. That means to say these 3 zeros which are reading are not significant. They are not going to be counted. But the zero after the trailing zero after a decimal point is significant. This zero, okay, the trailing zero after the decimal point there is what is significant here. So this number has 1, 2, 3 as 3 significant figures. Okay, 3 significant figures. Okay, this is our question 4. What about question 5? Okay, this is coming out from uncertainty in measurement, and you have been also been told to say this is a simple question. Okay, so the question is, if a measurement is reported as a 12.3 centimeter, what is the implied uncertainty if explicit error is given? To find the implied uncertainty, we're going to look at the number itself. Okay, we're going to consider about the digits which are after the decimal point. Since we have just one digit there, we are going to say the implied uncertainty will be 0.1. Okay, this is how you find it. Then we are going to say it is positive or minus. This is how you find the relative the implied uncertainty there. What if we had 2 digits here? We had 2 digits. How would have been our implied uncertainty? We would have said we have 1, 2. Okay, so this part we would have put 1, 0, and there 1. This is how we find the implied uncertainty. Our implied uncertainty would have been 0.01. Okay, what if we had 3? We had 3 and 5 there. We would have counted here, I've put 0, 0, then 1. Okay, we would have 0.001, then positive or minus there. Okay, this is how we should be finding the implied uncertainty. So here we only have 3 there, so we can't put 0 here. We'll just go direct and put 1. So we're going to have 1.0, so positive or minus. So this is our implied uncertainty. Now we can present our answer to be 12.3, positive or minus 0.1. Okay, so this is how you find the implied uncertainty there. Okay, the other question here, also basic on dimensional analysis, is also basic. What are the best dimensions in terms of length? Okay, what are the best dimensions in terms of length, mass, and time for velocity? Okay, let me check here. I don't have any space, so it's just to write from here. So, what do you know about C? Let me just answer from here on top. Okay, velocity, guys, is defined as the rate of change of displacement over time. Okay, and displacement is actually length. Okay, displacement is actually length. So the dimension of length is L. You guys watched the first video, so you're not going to find any problem with this. Then for time is T. I was saying that to take the denominator on top, it's going to gain a negative. So I'm going to have L there. Then T to the power now negative 1. Since it was a denominator, now it's because it's going on top. So these are the dimensions of what? Of velocity. Okay. What about question 7? Question 7, it is asking us to estimate. This is now on estimation and order of magnitude. Estimate the order of magnitude for the height of the typical adult. Okay, in meters. Okay, we have even been given the hint. That's why I'm saying this is a trust, because in an exam you can't be given this. It's more like a wreckage. They're telling you that the order of magnitude should be in this form. Like I was telling you, the order of magnitude is in the form of a power of 10. Okay, so after we find the height in meters, we're going to estimate it now in what? We're going to write it in the form of scientific notation, then we take it, the power of 10. So you can know that a typical adult man, okay, here we make an assumption. You can make any assumption, okay, but it shouldn't be out of the land. That's how we deal with the estimation. Okay, the typical adult can have the height of 1.7 there, 1.7 meters. Okay, 1.7 meters. I don't know if by now we have people which can go beyond. We can have maybe 2 meters, but 1.7, it is the what? It is the there we can have for the adults. Okay, now we're going to express this in scientific notation. That means we're going to multiply by, because scientific notation, guys, it is in the form m times 10 to the power n. Okay, where m, I said m should be less than 10. Okay, now we can see that this number is already less than 10 there. So we are going to say 1.7 times 10. Now if we don't want to change 1.7, we are going to put 0 on top, because any number raised to the power 0, it is just 1, which will mean that it will be just 1.7 times 1, which will still be 1.7. If we put 1, it's going to mean something else. It will change the answer. So are going to have this. Okay, this is, guys, and this, it's one and the same. Also it will be 1.7. now the order of magnitude, it is the power of 10. So the order of magnitude for a typical adult will be 10 to the power 0 meters. And this makes sense, guys. This makes sense, because if we had 1 on top here, we had 10 to the power 1, it would have mean someone can be 10 meters high, which is not normal for humans. Humans cannot be that high. Okay, if we are to put 2, we can have now 100 meters. No one can be that, can have the height of that. Okay, this can't happen. Okay, so 10 to the power 2, it is what? It is the normal order of magnitude for a human being. Okay, let's go ahead and do question 8. Convert 60 miles per hour. Convert 60 miles per hour. So this is a medium question to meters per second. To meters per second. Using dimensional analysis, okay, I always say that when you see per hour, it's like 60 miles, okay, over hour. We want to convert miles to hour there, okay. We want to convert miles to hour. What are we going to do? Okay, here's what we are going to do. I want you to check about this. Okay, one mile is made of 1609 meters. Okay, this is what I want you to see. And hours should be converted into seconds, and 1 hour is made of 3600 seconds. Okay, so what we are going to do is this. To cancel miles, we are going to put miles down there, and we know that 1 mile is made of 1609 meters there. Okay, to cancel hours, meaning hours must be on top. Okay, and 1 hour is equal to 3600 seconds. And this makes more sense to say we are going to have something like this. We are going to have something like 60 times 1609. Here we have miles, and here we have meters. Okay, here we have hours. Then down here we only have the digits. It is 3600. We have seconds, we have hours, we have miles there. Okay, now you can see that miles and miles will cancel, and hour will cancel. On top, we're going to remain with meters. So now when you multiply this, you divide by 3600, you are going to get 2.26.80 meters per second, because down here we remained with seconds. So this is how smartly bet that. Question. It is also a major question. Perform the multiplication 2.5, okay, 2.5 times 3.45, and report the result with the appropriate significant figures. Very important. So once you punch this on your calculator, you are going to get 8.55. Okay, that's my calculator. That's what my calculator is giving me. But what we are going to do, for us to report our answer, we're going to consider the number of significant figures here. So we have here, we have 2 significant figures. Okay, here we have 3 significant figures there. So now we are going to report our answer in 2 significant figures, because 2 significant figures is less than 3 significant figures. So we follow that one with less significant figures. It's the one which will determine the number of significant figures in our final answer. So our answer are going to stand here. This is where our 2 significant figures ends. What is the number next to that is 5. So since this is equal to or greater than 5, we're going to borrow 1 here to add to this. We're going to have 80.6 there. Okay, let's go ahead and do question 10. At least we are seeing a change, guys. We are seeing a change. So the question here is, if you measure the length of a table to be this, okay, and its width is this, calculate the area, and its absolute and its eternity. Okay, so here is what I want you to be showing you, guys. Okay, the area is given by a length times the width. Okay, now when you see a number is in this, Okay, when you see a number is in this form, we have 2.50 meters, positive or minus 0.05, and we have been told to say this is our length. That means this is the length and this is the what? The delta L, which is the uncertainty length. That's how we call it. What about this part, which is the width? We are going to name it by B. It is 1.20 meters, positive or minus 0.03 meters. Okay, how you do it. Okay, now even here we're going to say this is going to be our breadth, and this is our delta B. It is the uncertainty now in width there. Okay, so now to find the area, we're going to say our length is this 2.50 there, multiplied by our width is 1.20. 1.20 is equal to once you punch this on your calculator, you're going to get it's giving 3.00 there. This is how you find. Don't forget to use right units. Meters area, it's meters squared there. Okay, so now how are we going to find now the absolute uncertainty? Okay, so the first thing is to write the formula for the relative uncertainty. The relative uncertainty of A is going to be given by delta A. Okay, delta A is not delta. Let me write it here, delta A there over A. Now, here we have two quantities here, the length, we have also the what? The width. So we're going to add the two. We are going to have delta, the relative uncertainty in length, okay, which is given by delta L over L plus the relative uncertainty in width there, delta B over B. Okay, now the absolute uncertainty, guys, the absolute uncertainty, this, when you see delta A over A, it is not the absolute uncertainty. This is the relative uncertainty. This is the relative uncertainty there. Okay, the absolute uncertainty, it is this part which is on top, delta A. So now to make delta A the subject of the formula, that means we're going to multiply by A everywhere. We multiply by A, we also multiply by A. That means our A and A here will cancel. Our answer is now going to be, our delta A is going to be remaining to be delta L over L plus delta B over B, then we multiply by A there. So now replacing the given values in the formula, our delta L is 0.05 over our L is 2.50 there, plus our delta B is 0.03, then our B is actually 1.20. Then our area is what we found to be 3 there. Okay, so now once you punch this on your calculator, you're going to get what? Okay, you're going to get our relative uncertainty, our absolute uncertainty. I'm thinking about that question for velocity too much. So our absolute uncertainty of area is going to be, after we round it off, I'm going to get 0.14 meter squared. Okay, so this is our absolute uncertainty, and this is what our area. Now we can represent our answer in the form of area, positive or minus delta A, which is going to be, now our area is 3.00 meter squared, positive or minus 0.14 meter squared there. This is how you present now your answer. So guys, you should be following the steps like the way I'm presenting my work there. This is how you should be answering when you are asked in your test or in your exam. Okay. question 11. Check if the equation for kinetic energy. Okay. Kinetic energy is given by half mv squared. Actually, this is true, though we have not yet checked. Okay, it's dimensionally consistent, where m is mass and v is velocity. So we are asked to show our work. Very important. So to show if an equation is dimensionally correct, guys, we are going to show the dimension to our left hand side and also to our right hand side. And we are going to compare. If they will match, that means it is dimensionally consistent. If the dimensions won't match, it will means it will be incorrect. So now I want you to think of here to the left hand side, we only have kinetic energy. Kinetic energy, guys, is the same as work. In terms of dimension, it is same as work. Okay, it has dimensions with work, just as we have the same units. Here it is measured in joules, even work is measured in joules. So even the dimensions are the same. Now I want you to look at this. Work is given by force times distance there. Okay, force times distance. What are the dimensions of force? That's why I'm saying that if you miss that, it will be a very big problem if you missed the video. So okay, let me just show you. Force is equal to mass times acceleration there. Okay, then mass, the dimensions of mass is actually m, and the dimensions of acceleration, it is L, then it's t to the power negative 2. If you missed this, guys, go to the video because we are going to have a big challenge. I shared this. Okay, here is what you should now follow. So where there is a force, we are going to replace this in this formula. We want to find the units for what? For kinetic energy. And the distance, guys, it is actually length. Okay, so multiplying the two, it is like we are going to have our m, then L there. I'm following this L. Now we are multiplying by another L here. We are going to have L squared. Okay, then T here to the power negative 2. Okay, so here are the dimension to our left side, we keep it. What about to our right hand side? To our right hand side, we are going to have the dimensions of m v squared. We ignore half because it is a constant, it is dimensionless. So what is the units? The dimensions for mass is m there. Okay, the dimensions for velocity is what we were finding in the previous question, I think question 3, which was L to the power L to the power t to the power negative 1 there. Okay, now think about this. We have been given v squared. That means we are going to square this. We're going to square this because you have v squared, not v. So we're going to have L squared, then t also squared, because it is negative, we're going to have t to the power negative 2 there. Okay, now multiplying the two, we are going to have our m v squared there to be m, then L squared, also t to the power negative 2. Now check for me this. Okay, check for me this. These dimensions and this dimension are equal. So I'm going to conclude to say our dimension to our left hand side are equal to the dimension to our right hand side. Hence the equation is dimensionally what? Consistent. This is how you show. Okay, this is how you show. Okay, we go on question 12 is on estimation and order of magnitude. Also estimate the number of breaths a person takes in one day using order of magnitude reasonings. Assume a reasonable breathing rate. Okay, so the breathing rate, guys, the breathing rate of a person at least, a normal person, not a sick one, because they have different breathing rate. So a normal person has a breathing rate of about 12 to 20, 12 to 20, 12 to 20 breath per what, per second. This is what you need to know. I mean per minute. Can't take those breaths per second, per minute. So this is just the range. Okay, so we can take now the average breathing. Okay, the average breathing rate we can take to be, let's take 15, the number in between here. We can take any number. Now I would like to take 15. You can take any number, guys. So come to estimation, guys, just make have the reasonable, the typical assumption. Okay, then after that you can take any number within the average there, within the range. So here I 15 breaths, I mean 15 breaths, 15 breaths per minute. So a person takes 15 breaths per minute. Now we are asked to now how many that this person is going to take now per what, per day, because that is why that question. So we're going to convert this. We are going to say 15 breaths. Okay, hover. Now we have minutes there, down there. Okay, we have minutes. So now what we want to cancel, it is minutes. Okay, we can convert minutes to hours. So to cancel minutes, we are going to take we say 1 hour there is made of 60 minutes. Now what can we do to cancel hours to days? We are going to say one day is made of 24 hours. So the arrangement of here, it matters only when we want to cancel some units. It's not to be putting meters on top of hours, guys. Okay, sometimes it changes. Okay, what we want is to cancel meters. That's why we take that on top, and hours may cancel. So here it means that we are going to have 15 times 60 times 24. Then on top we have breaths. So it's taken three a certain breaths per watt. Now we remained with the day there down. Okay, so our answer now is going to be, when you multiply that, you're going to have 21,600 breaths per day there. Now the question is to find the order of magnitude. So to find the order of magnitude, what we are going to do, we are going to write this number in standard notation, okay, in scientific notation. Okay, so here's what you are going to do. You are going to press our point. You are going to move. You say 1, 2, 3, 4. Okay, you are going to set to be, our answer is going to be 2.16 times 10 to the power 4. Okay, now think of this. The order of magnitude is the power of 10. So the answer is going to be 10 to the power 4 breaths there, breaths per watt per day. This is going to be our answer. So if you want guys to prove this, use any number. Use now 12. Use any number between the 2 up to 20. Use this. You replace here. You are going to find that your answer will always be 10 to the power 4. That is the interesting part about order of magnitude. You can number within the length, but the answer will always be the same. So let's do question 13 on the other page. I want to finish this on time. Okay, our question 13. We have been given a car's efficiency to be 25 miles per gallon. And we are asked to convert now this to liters per 100 kilometer. This question is very interesting, and that's why they said hard, because there's some things which you need to think critically there. Okay, so here's what we are going to do. As usual, we're going to write 25 mile there. Okay, 25 mile over gallon, there. So now, what we want is to convert to liters per 100 kilometer. So in the first place, we are going to convert into what? Into liters per what? Per kilometer. We forget about this 100. So to cancel now meters to what? To kilometers. We are going to say, since mile is on top, we are going to say 1 mile is given by 1.609 kilometer there. Okay, now how can we cancel gallon? Okay, the conversion factor you need to know about gallon is that 1 gallon, okay, 1 gallon, 1 gallon is equal to 3 point, this you need to know, 3.785 liters. Okay, so we're going to say, since gallon is on the denominator, it's going to be on top because we want to cancel it. 1 gallon is equal to 3.785 liters there. So what we do is now to cancel this, and this will go, gallon and gallon will go. Now you can even tell to say we've just remained with kilometer per liter there. So as you can see, we can now do 25 times this. Okay, now the answer we divide by this. Okay, so we are going to get our answer to be, our answer is going to be 0.094 kilometer, because we have kilometer per liter here. We have kilometer per liter. I want you to follow this question very closely. Without following it very closely, you will fail to answer this question. Now look at this. We have been told to find our answer in liter per what? Per 100 kilometer. But as you can see here, we have in the form of kilometer per liter, which is not even matching. That means we are going to flip the equation here. I mean the expression, for us to have liters on top and to hand kilometer down there. We're going to say L over kilometer there. Okay, this is going to make, now after doing that, even here we are going to change, since this is same as 1, okay, this is same as 1 over 1. So now we are going also to change it to be 1 over 0.094. Here you don't need to get confused, guys. This divided by 1 is just the same. Okay, now since we are changing these are changing, this fraction is also going to change. Okay, it is also going to change. Now I think I made a mistake. Okay, after you multiply out, I was very ahead. After multiplying this and this, then you divide by this, you are going to get 10. Okay, you are going to get 10.627. Okay, you can take this as now our true value. Okay, now we are dividing by 1, so we're going to have the real part now is going to be, we are just doing the same. We're going to have number 1 over 10.627 there. Okay, then we have liters per kilometer. Okay, so now dividing this into this, okay, dividing 1 divided by 10.627 is where we are going to get 0.094. Okay, 0.094 then liters per kilometer there. Another thing we need to think is, still here we still have 1 over 1. It doesn't change anything. Now here is what you want to think here. Critical thinking. I think this question I've got it can come in your test. Can come in your test, this question. Here's what I want you to see. We have liters per 100 kilometer, but what we have just found is liters per what? Per kilometer. So to add 100 here, we're going to multiply both the numerator by 100, also the denominator by 100. Okay, so this times 100, this times 100, we're going to have 9.4. 0.094 times 100, we're going to have 9.4 there. 9.4 liters per. Now 100 times kilometer, it is 100 kilometer. This is how you handle this kind of a question. Guys, familiarize yourself with this question. This question, in fact, it's the only trick question I've seen in this tutorial sheet. The rest, they are just seeming to be when you are reading it, but they are very simple to answer. Okay, now let's do this question. Add the following measurements and report the value and report the sum with the correct number of significant figures and the uncertainty. Okay, here is what you need to know. These parts are the values. This first part are the values, and the other part here are the uncertainty. So we're going to add this independently. So we're going to first add the values. We have 12.53.52 plus 3.4 plus here 0.123. Now the trick part of this, when you are adding decimal numbers, our answer is going to be represented in that answer with what? With the small what? With the smaller number of decimal places. So as you can see here, it has two decimal places. Here we have 1, here we have 3. So our answer should have 1 decimal place. That happens when we are adding and subtracting. When we are multiplying, we follow the answer with the small significant figures. That's how we do it. Okay, so adding the 3 there, we are going to get our answer to be 16.043 there. Okay, 43 centimeters. But our answer should have 1 decimal place. So our answer is, we are going to stand here, since 4 is less than 5, our value is going to be 16.0 there centimeter. Okay, now to add the uncertainty are these values. Now we have 0.05 plus 0.2 plus 0.001. Okay, here we are all in centimeters there. So adding these guys, we are going to consider also, this has how many decimal places? We have 2. Here we have 1, here we have 3. So our answer should have 1 decimal place. So adding the 3, we are going to get our answer over. Our answer is going to be 0.251, okay, centimeter. But we want to have 1 decimal place, so we're going to stand here, and we see, since this is equal to 5, we're going to take 1 to this. It's going to be 0.3. Okay, these things are very, very simple. So we're going now to represent our answer as 16 centimeter, positive or minus 0.3 centimeter. This is how you represent your answer. It is very simple, though it has been mentioned to be a hard question. Okay, yeah, this is now the part which most of you guys are getting confused here, and I'll try by all means to be slow on this part, though I'll be not that much slow. So the question is, using dimensional analysis, derive a possible formula for time, okay, of a simple pendulum, assuming it depends on length, mass, and acceleration. And I've been said, take note that the actual formula ignores m but show the process. Okay, now here's what you need to do. We have been said, find the formula for time. Okay, I'm going to say our period is going to be equal to, okay, it's going to be equal to our length here, our length L then multiplied by what? It depends on what? Also on mass. Okay, we say times mass there. Okay, also on acceleration. Okay, now here is what you are going to do. Okay, here is what you are going to do. What is on the left hand side? What is on the right hand side? You are going to raise this to some power. This is what you should be doing. You have a to the power b, also to the power c. Okay, to the power c there. So what are you going to do next? Okay, what are you going to do next? Here's what you're going to do. We're going now to write the dimensions. Okay, the dimensions of time. Okay, the dimensions of time is actually t. Okay, is actually t. Okay, now I want you to see this. I want you to see this. What we need, we have here, or let me also just show everything. The dimensions for L length is actually capital letter L, but this it is raised to the power a. The dimension for mass is m, but it is raised to the power b. Okay, the dimensions for d, it is acceleration. Okay, acceleration guys is given by L, then t to the power -2 there. This is what I've been talking about. Now, since it is raised to the power c, it means here we are going to have c, also here c. This is what it means. We are multiplying out everything. So we're going to have L to the power c there, and t to the power -2. Now I want you to see this. Here we have m and L, but this side we don't have. So what we are going to do, guys, we are going to add m here. But since we don't have this to this side, we are going to set to the power 0, even L to the power 0. Because what we need to know that any number raised to the power 0, it is 1. So it is like 1 times t. We will still remain with the t. Okay? We will still remain with t. So t, we can say t to the power 1. It doesn't change anything. Okay? So here we are going to now simplify this. We want to simplify this. M to the power 0, then L to the power 0, then t to the power 1. Now L times L. Okay, so if you are multiplying the same bases, we add the powers. So we're going to have L, then A, we have A plus C there. A plus C. Okay, what about M? We just have a single M there. It is M to the power B. It is M to the power B. What about here? We have T. Our T is here. Okay. T is raised to the power -2c. It is -2c. Okay. It is T there to the power -2c there. Okay. Now, what you are going to do next, I want you guys to be following step by step this part, so that the next question on the related question, I will try to be faster. Okay. What you are going to do now, you are going to equate this. Okay, you are going to say what is with m here. Okay, we are going to have m to the power 0 to be equal to m to the power b. Okay, what is L? We have L to the power 0. We have L to the power 0. Also now here L to the power a plus c. Okay, what else? What else do we have? We have t here. Okay, we have t to the power 1 to be equal to t to the power now here -2c. Okay, now look at this. That means since we have m and m will cancel. Okay, so our b is equal to 0. So we're going to equate the what is on top. So our b is equal to 0. Don't miss it here. So here L and L will cancel. We're going to have our 0 to be equal to A plus C. Now, here and here also will cancel. We're going to have our 1 to be equal to negative 2C. Okay, so these are our equations which we have. Already B we have, it has been solved already. So to solve for C here, to solve for C, we're going to divide by negative 2, also by negative 2. That means our C is equal to negative half. Okay, now to solve for A using this equation, we can solve for A. We have 0 is equal to A plus C. So to solve for C, we are going to take C to the other side. It is going to be our negative C is equal to A. Okay, since negative C is negative 2, we're going to say where there is C, we're going to put negative half there. I mean half is equal to A. Negative and negative will cancel. We're going to have our A to be equal to half. Okay, so these are our given values. These are our given values which we have. Okay, here. So now we are going to go back to the first equation we made and we are going to replace the given values. Okay, this is what we are going now to do on the next page. I want you to follow closely because some of these questions will come in your test. Okay, so our assumption was C was equal to our M. Was it our M? It was our L to the power A, our M to the power B, and our C to the power, our G to the power C there. Okay, and we find our A to be half, our C to be negative half, then our D, our B to be 0. Okay, I want you even to see why they said ignore the M. You are going to see where our M is getting eliminated in the formula. This is the important about dimension analysis. So I want you to see this. Why there is A there, we're going to say T is equal to, why there is A, we are going to put half, so L to the power half there, and M to the power 0, since B is 0, and G to the power negative half. Now, law of indices, you learned that if any number is raised to the power half, is same as square root of half, square root of that number. Okay, now if a number now is raised to the power, what if now we have M to the power negative half? What does it mean? It will be now 1 over square root of M. This is what you need to remember, guys, from law of indices. That means our period now is going to be L is going to be, since it is raised to the power half, is going to be square root of L there. Then M, any number raised to the power 0 is just a 1. Okay, so we're going to multiply by 1 there. Then we multiply by G is going to be, now it is in this form, it's going to be 1 over root of G. Okay, over root of G. So what else can you do now? We can multiply this. We're going to have our L times 1 times 1, then the denominator is actually root of G. From such, guys, you who are registered in mathematics, I was telling you that dividing this is same as dividing them directly under the same root. So we're going to have our formula to be our L over G. Okay, and this, guys, are going to remember it now, because in equation we may have a constant. We may have a constant in any equation. You can put our K here. Our K here. Okay, and you can our K by commenting to say the a constant here, K to remain to stand for a constant. A constant is dimensionless, so our equation is going to be just L over G. Remember this formula, guys. We are going to use it in semester 2, and it will be like 2 pi L over G. we are going to use this formula 2 pi to remain to stand for constant in this case, but your answer should be like this. So this is how I've explained it now step by step. The other questions try to be fast. Try to be fast so that we finish on time. Okay, question 16. On estimation and order of magnitude, estimate the total mass of all the hair in a typical classroom. State your assumption and use order of magnitude calculation. Okay, so we want to estimate the total mass of hair in a typical classroom. Okay, so let's think about hair. Let's think about hair, guys. Okay, so hair has got in the classroom, air has a density, because the density of hair in atmospheric temperature, the density of air is actually 1.2. This is a typical assumption you need to have. Okay, this is the density of hair which you need to know. You need to know, guys, these assumptions. Okay, what else do you need to know? Another thing you need to know now, we can see that we want to find the mass. So the formula that corrects density and the mass is going to be density is equal to mass over volume. So to find the mass, we're going to cross multiply. Here we're going to have mass is equal to density times volume. Okay, now how can we find the volume of air? Since this air is in the classroom, we are going to find the volume of the classroom. Okay, so the assumption we're going to make for a typical classroom. The typical classroom, guys, can have the length of 8 meters. Okay, you can make it 10, you can make it 9, but it shouldn't go very far. A classroom can maybe up to 10. Okay, so I pick 8. Then the breadth can be maybe 6. Okay, it can have a breadth of 6, which is the width 6 meters, and the height, the classroom can have a height of 3 meters there. It is enough for a classroom. Okay, now to find the volume, what you are going to do, you are going to say, you know that volume is equal to L times B times H there. Okay, so while there is this formula, we are going to replace our L times B times H. So we're going to have our mass is going to be density times L times B times H there. So our mass now is going to be, our mass is 1.2 there. Okay, we have 1.2. Our length is 8, our width is 6, and our height is 3. Okay, multiplying out this, we are going to have our answer of 172.8 kg, because we are finding mass there. Okay, now to find the order of magnitude, we are going to convert this in scientific notation. So we are going to move our decimal place here, 1, 2. Okay, we're going to have our mass to be 1.728 times 10 to the power 2, because we moved 2 times there, kg. Okay, so now the order of magnitude is just the power of 10. So our mass, the order of magnitude in mass is 10 to the power 2 kg. Go ahead and change the dimensions there. Dimensions of a classroom to be here 9. Here you try 6, same 6. Here you try 4. You still have 10 to the power 2 as the what? As the order of magnitude. That's the interesting part about order of magnitude. Okay, let's do question 17. It is also on dimension analysis, and it has also been mentioned to be the hard question. Let me try to drive the formula for the speed of a wave on a string under tension F with linear mass density. This is the symbol for linear mass density, and using dimension analysis. So we want to find the formula. This is same as question 15. We want to find the formula for the for the tension, okay, the tension is actually like force, it's same as force. For the tension F, okay, with linear mass density here, what have we been given, guys? Sorry, it is the speed. If you want to find the formula for speed, so it's actually V. Now, under a tension F is equal to F, then with linear mass unit, here is what you are going to, this is what you've been doing, guys. Okay. So now, I want you to remember that our velocity in the first place, the dimensions for velocity is g to the power -1, and the dimensions of force is mass times acceleration. That's why I like memorizing. So mass is m, then acceleration is L, then g to the power -2. Okay, what about linear mass density? Linear mass density, guys, is defined as mass per unit length. So linear mass density is given by mass over length. So to derive the dimensions for linear mass density, we say the one for mass is m and the length is just L. So taking this on top now, we are going to have, it's going to be negative. So we're going to have our m, then L to the power -1 there, because it has gone. So now let's go ahead and replace the given values. The derived our derived dimensions into the formula. Why there is V, we are going to replace this. Okay, we're going to say our L, then t to the power -1 to be equal to, why there is F, we replace this. We're going to have our m, then L, t to the power -2. What else? We have linear mass density, we have m, then L to the power -1. Okay, now I want you to see this. I want you to see this. I want you to see this. So what we are doing here, we are going to do this. We are going to do this. Here we don't have m, but here we have m. So I said we can say m to the power 0. Okay, m to the power 0. So now I want you to see this now. Look at this. Here we're going to write like the way it is, m to the power 0 L, then t to the power -1 there. Then mass times mass there, we are going to have m squared. Okay, we're going to have our m squared. Actually, I forgotten to add powers here. Okay, you can add powers like x and y. Yeah, very important. So that the one for force is going to have x here, x here, also x here. Okay, so it is x here, also x here. This is the part I forgotten. Okay, what about here? The linear mass density is raised to the power L. That means we're going to have our y here, also our y here. Now because it is -1, so we're going to have -y, because -1 times y, it is -y. So here we're going to have y, then negative y there. Okay, now this makes sense. Okay, let me now eliminate that part. It was a mistake. Okay, so m raised to the power 0, then L, then t to the power -1 there. Okay, now m times m, I was saying that when we are multiplying some bases, we had the powers. We're going to have x plus y there. What else do we have? We have L times L here. So we're going to have our L here. We have x Now, because this is negative, we're going to have negative y there. Okay, then t, we just have t to the power negative 2x. So we can now start equating. M and m are going together, so I'm going to equate 0 to this. Okay, I'm going to have 0 is equal to x plus y there. The other equation is for L. L, we are going to say it is raised to the power 1 here. So it is 1. What is for L here? It is x minus 1. What else do we have for t? We have t to be negative 1. Okay, negative 1. Then to the power negative 2x there. So from this, we can solve for x. It is well simplified, negative 2 over negative 2. So our x is equal to half there. Okay, our x is equal to half. This question is very, very interesting also. Actually, I can even remember this. This formula is given by this. But we are doing the calculation. You don't need to know the formula. You need to use dimension analysis. Okay, I just remember it as I'm doing the calculation here. So what are we going to do now to solve for y? We are going to use our formula here. Okay, we are going to use this to make y the subject of the formula. To make y the subject of the formula, this x is going to the other side and it will become negative x. So our y is equal to negative x here. So this question seems to be the same. Okay, our y seems to be negative x there. So what we are going to do now, negative y, that is x, we put our half there. So our y is equal to negative half. Okay, so now since we have this, let's go and press into the formula which we found into this. Where there is x, we put half, and where there is y, negative half. This is what we are doing. Okay, so we add our volume. I mean our volume. Is it our volume we are talking about here? It is the speed, not volume. Our speed now is going to be f to the power x, then linear mass density to the power y, where our x is half and our y is negative half. This question, guys, are very important. Be asked. Let me be asked. If it would be the same question, it will be this of the same kind. So what you just need to do, guys, solving is not the problem. Okay? But accuracy in solving matters. Also, the other thing is about knowing the law of indices. You also know the dimensions. Because if you forget the dimensions for force, it will be very difficult for you. So the first video is the key to understanding this story. So f now to the power half and y, and I mean linear mass density to the power negative half. What I said, when a number is raised to the power f, to the power half is like the square root of f times, when it's raised to the power negative half, it is 1 over root of that thing. Okay, now multiplying the two, we are going to have there square root of tension there over the linear mass density there. Okay, where we can write this under the same roots, so to be our f over linear mass density there. So this is the I was actually talking about. So this is how you find that formula. It is very, very simple. We are almost concluding. Okay. Question 18. Okay. For a volume of a sphere 4 over 3 pi r squared there. If the radius is given to be 5.00 centimeter, positive or minus 0.05 centimeter. Calculate the volume and its relative and how it uncertainty using propagation of Euler laws. So you have three things which you need to find: the volume, the relative uncertainty, and the absolute uncertainty. To find the volume, okay, because we know that this is the radius and this is the uncertainty in the radius. Okay, this is what you need to know. Now what you are going to do is this: to find the radius, the volume, we're going to say 4 over 3 pi. Where there is hara, you put 5, then to the power 3. So our volume is going to be, once you punch this on your calculator, you're going to get 523.6 cubic centimeters. The units are very important. This is the volume. This is our first part. Okay, our second part now is to find the relative uncertainty. Okay, now the relative uncertainty, guys, the relative uncertainty of this is going to be written as delta V over V to be equal to the relative uncertainty of radius will be going to be now delta R over R. But here's what I want you to see. This part, guys, when we are dealing with now the relative uncertainty, we ignore the constant. 4 over 3 pi, it is a constant. So the equation is going to remain to be, velocity is going to be, the volume is going to be cubic radius there. What does this mean? Okay, so this means that the relative uncertainty in volume is 3 times the relative uncertainty is what in radius, because of these 3. So some tutors, they just go there and can tell you that if you have the power of 3 there, just put 3 here. Okay, but this is what it means. It means that the relative uncertainty is 3 times the relative uncertainty of of radius. So to find the relative uncertainty, guys, you say delta V now over V to be 3. Delta R is this part. I've been saying about this for too long now, times 0.05 over the radius, now it is 5. Okay, so our relative uncertainty is going to be, which is part 2 in this case, our relative uncertainty, once you punch this on your calculator, you're going to get 0.003. Okay, 0.03 there. This is our relative uncertainty, and it has no units. Okay, because here we have centimeter, and centimeter is going to cancel. Okay, now what is the absolute uncertainty? What is the absolute uncertainty? The absolute uncertainty, guys, it is this part on the top. Okay, since we have our relative uncertainty, our delta V over V to be 0.03. Okay, to find now V, we're going to say over 1 here, we cross multiply. 1 times this, we're going to have delta V to be now V multiplied by 0.03, because this and this are going to multiply. So our delta V is going to be, our V is the one we found in the first place, 523 there, 0.60, multiplied by 0.03. Our delta V now is going to be it's actually 15.71 cubic centimeters there. This is how you handle this kind of equation, step by step. Let's do question 19. Almost concluding. Question 19. A physicist estimates the order of magnitude time for light to travel from the sun to Earth, the distance of 1.5 times 10 to the power 11 meters, the speed of light to be 3 times 10 to the power 8 meters per second. Then using dimensional analysis, check if the formula distance over speed there, because it is standing for speed in this case. Check if the formula is actually correct. I think I use white, it's been long. Okay, what you need to know, here's what I want you to do. I want to now we've been using dimensions to check formulas. We've been using dimension. Now here I'm going to use units to check the what? The equation if it is correct. Okay? What you're going to do is this. Okay, the dimensions of time is second. I mean the units of time is second. The units of distance is meters. Okay? We are dividing by the units for speed is meters per second, which is can be written as meters over seconds there. Okay, now let's ignore about this other part because we already have s there. So we're going to have meters. For to change has to multiplication, we're going to flip the fraction going to be s over m. That means this and this are going to cancel. We're going to have our s is equal to s. You can tell to say the left hand side is all equal to our right hand side, hence the equation is what is dimensionally correct. You conclude like that. Okay, now the other question is, then use dimension analysis to check if that is correct. Okay, this is what we are doing. Finally, convert time to minutes. Convert the time to minutes with appropriate significant figures. So to convert time to minutes, it means we first need to find time. The distance is 1.5 times 10 to the power 11 meters. Okay, and the speed is 3 times 10 to the power 8. I'm using this formula, guys, don't get confused. Meters per second there. Okay, so our time, guys, our time is going to be our time is just going to be 0.5 times 10 to the power 3 seconds there. Okay, now here this part I can change it to 5. Okay, changing it to 5, 0.5 can also be written as 5 times 10 to the power negative 1. Try this out on your calculator. It's going to give you 0.5. So my time is going to be, now this is going to be replaced by 5 times 10 to the power negative 1 times 10 to the power 2 there. I mean 3 seconds. Okay, so now what are we going to do? What are we going to do next? We are going to say our time now is going to be 5 times 10 to the power negative to the power 2 seconds here. So now we want to convert now this in 2 minutes. Okay, we want to convert this into 2 minutes. So converting this in 2 minutes, guys, here I give you the work. Go ahead to convert in 2 minutes. I'm going to divide by 60 times 10 to the power 2 over 60. Go ahead and find the answer. Okay, I'm run out of time, so here you can't find your answer no matter how tired you can feel, because the only thing that can cause you to fail this is when you are tired because you don't know. It's the matter of punching that on your calculator. Okay, question 10, guys, is like what I've been doing. From the first video there was this question, from the second there was this question, from the third there was this question, even this time it is there. So now here Newton's law of universal gravitation is given by this formula, and you have been told to say we have been told to say let me change the color maybe so that I may be pointing clearly. Our F is gravitational force, M and M are masses, and R is length. Then you have to find the units of G if force, the units of force is this. Okay, so I've been given this formula, guys. MM over R squared. I still have a space here? Let me check for the space. Okay, I still have a space. So to get rid of this, we want to remain with D. We want to make D the subject of this. I'm going to multiply this by R over M. Our M is this and this to cancel, and R and R to cancel. So what we have done here is what we are going also to do this side. Our R times M times M. So our D now is going to be F times R over M times M. Okay. Now the units of force is kg, then meter per second square. What is the units of R? R is distance, it is meters. Okay. On down here we have kg. Okay, we have kg. Also, even here, since both are masses, we are going to have another kg. Okay, so look at this, kg and kg are going to cancel. Okay, kg and kg are going to cancel. That means on top we're going to remain with meter per second square there over kg there. So meter per second square there over kg as the units of G. We are looking for the units of G. So what we are going to do, guys, this means we can take G on top. Okay, we can take G on top, it's going to be negative. I mean kg on top is going to be negative. Kg to the power -1, then meters per second square there. If you want, you can also change this. Because to get rid of the slash here, we're going to make it also negative. This is what we do. These are the units for what? For gravitational constant there. Also, this question, I'll be doing the same question throughout. Okay. So, the question here, we have been given the kinetic energy, the units of kinetic as dimensions. These are the units for kinetic energy. And it can be written in terms of momentum and mass. Determine the proper units for momentum using dimensional analysis. Okay, you've been given this. Okay, so what you are going to do, guys, what you are going to do is this. Okay, we're going to make it momentum the subject of the formula. We're going to have over then this times this, we're going to have 2 kinetic energy times m. What we need to know is that this is dimensionless, and we are going to cancel it. Now to remain with p, we're going to have square root of kinetic energy times m there. Okay, now look at this. This is our formula now. Let's go ahead and finish our kinetic energy times m there. Okay, what are the units of kinetic energy as have we been given? Okay, I've been given to say kinetic energy. Let me check. Kinetic energy is kg meter squared per second squared there. Okay, kg then meter squared per second squared. Now we are multiplying by m, which is actually mass there. Okay, which is also kg, because the units for mass is kg. So the units for momentum goes as kg times kg. You're going to have kg squared, then meter squared over second squared. So since these are under the square root, all the squares are going to cancel with this, the square root there. Okay, so our answer is going to be kg meter per second there. Okay, this is how you find the units. This makes sense, guys. If you have a calculator, try square root of 2. You are going to get 2. I mean square root of 2 squared. You are going to get 2 because 2 and this are going to cancel. That's why the 2 are cancelling there. Okay. I'm trying to finish this on time. This is the long tutorial sheet. I'm even draining out there. So the period of a simple pendulum defined as the time necessary for one complete oscillation is time units and is given by the formula here, where L is length and G is the acceleration due to gravity. In units of length they are divided by time squared. Show that this equation is dimensionally consistent. Okay, as usual, we are going to show the units, I mean the dimensions, in both our right and our left hand side. First of all, we're going to omit the constant, so our formula is going to remain to be T, then L over G there. What I do for me to be fast with dealing with this kind of equation, here's what you are going to do. Okay, here's what you are going to do for 5 things. You are going to say, you're going to square everything. We square here, we also square here. Okay, I'm going to have T squared is equal to, now squaring this will just cancel the square root, so I'm going to have with L over G. The dimension of T is actually T there, T squared. Okay, what about to this side? We have L. The dimensions for L is length there. The dimensions for acceleration, we are dividing. The dimension for acceleration is L over T squared. It is L over T squared. Okay, so let's go and simplify this. I still don't have a space, so I have to finish my work here. So we have T squared here to our left hand side. So changing this, guys, we're going to have our L times, on top we're going to have T squared. Now L will come as the numerator. That's what we did. So L and L are going to cancel. So I'm going to remain with T squared, also a T squared. You can now tell to say that the left hand side and the right hand side are all equal. Okay, so the equation is dimensional what? Consistent. We are finishing and very soon. Okay, all these questions I did have answered these questions before. So for you guys who even watch this, you can even skip this. Suppose the displacement of an object is related to time according to this expression. What are the dimensions of B? This is our height. The expression is x is equal to b t squared, where x is the displacement and our t is actually time. To find the b, we're going to make b the subject of the formula. Okay, we're going to divide by b. I was checking if I still have another body there. Okay, so this sorry, we're dividing by t squared. I'm very busy. So t squared and t squared will cancel. Our b is going to be x over there. Now, as usual, the dimensions of our x is displacement. This is actually length over t squared. We can change, if you want, we can take t to the power to on top is going to gain a negative. We're going to have t to the power negative 2. These are the dimensions of b. Okay, now question 3, I mean question B. I've been told that a displacement is related to time as x is equal to a sine theta, a sine 2 pi frequency times time, where a and f are constants. Okay, here this a and f are constants. Find the dimensions of a. Okay, int, a trigonometric function appearing in an equation must be what? Must be dimensionless. This is what I want you to hear. Okay, so our formula is a sine 2 pi ft. So what you need to know, guys, what you need to know here, we have been told to say f is dimensionless. We already know in the equation been told that the trigonometric function appearing in the equation must be dimensionless. That means these all parts, because the sign is being multiplied by everything here, that means it is going all to be dimensionless, and the dimensionless part is always eliminated. So we're going to have x is equal to a. Now what does this mean? It means that the dimensions of x and the dimensions of a are equal. Since the dimensions of x is L, so the dimensions of a will be L. What a very simple question. If you find this question, just even feel good, but don't get too much excited. You can fail the question. Okay, let's do the last question. The last one, we've also done this question before. A shape that covers an area A has a uniform height and a volume given by area times height. Show that this formula is dimensionally correct. As usual, volume, guys, volume is given by L B8 for an irregular object there. Okay, what you need to know is that L, the dimensions of L, it is L. The dimensions of B is also L, and also the dimensions of 8, it is also L. So multiplying the two, the dimensions now are going to have L to the power 3. That's why the dimensions of volume is always L to the power 3. The units are always cubic meters, cubic centimeters. It is because of this which I've just shown you here. So now we have done to the left hand side. Let's go ahead and do to the right hand side. Let's find the dimensions of area times height. Okay, area is given by LB. Okay, then height is 8. Can't you see that this and this are the same? So even the dimensions are going to have that of L, that of B, that of 8, which is also L, which is L to the power 3. So I'm going even to say that the dimensions from the left hand side, to our right hand side are equal. So this equation is dimensionally correct. Do I have the last part? Okay. So the other part I failed to upload there. So the other part is now we have shown. The first part is to show if it's dimensionally correct. B is to show that the volume of a cylinder and the volume of a rectangle, the volume of a cylinder and the volume of a rectangle can be written in this form, where A, identifying A in each case. Okay, let's do this. Okay, here's what you're going to do. I've been given our main formula to be this, and first you want to show that the volume of a cylinder can also be written as this. Okay, the general formula for the area, for the volume of a cylinder, is given by base area times height. Okay, now the cylinder looks like this, guys. Not good at drawing. Okay, why this is the circle on top. Okay, so the base of a cylinder is just a circle. So the base area here is pi. Okay, so the area of a cylinder, guys, I mean the volume of a cylinder is going, the base area is that of the circle. We're going to have pi r squared. Then we have the height here. This is why you have been told, ready to say this is the volume of a cylinder. Now I want you to see this. The area of a circle is given by pi r squared. So where there is pi r squared, you're going to replace the letter A. This is going to be replaced by A. We are going to remain with H there. NC shown. What about the area of a rectangle? Can it also be written in this form? The area of the rectangle is given by L times B, then the height here. Okay, this is the base area, and this is the height. So now the area is given by HLB. So why there is HLB, guys, replace the A. A basic equation. I don't know why it is even the last question. Okay, so this is how, guys, you can show the area of a cylinder. So this marks the end of our tutorial sheet 1. So guys, just watch this video as you have watched, go through the question, master them, know how to handle, get the knowledge from this video, how you can apply to other questions. Don't only master the answers, okay, because these questions, some are going to be in your exam and in your test. Okay, so this is the end. Thank you for watching, and all the best for you guys. If it's your first time, don't forget to subscribe to my channel, you like, and also share.